This video is to quickly demonstrate to you how to use files in C. So we'll go into various aspects, but firstly we'll look at text files, how to write into a text file, and then also how to read from a text file. Then we'll look at binary files, how to write to a binary file, and how to read from a binary file. So basically, to use a file in C, you need something called a file pointer. And I'm just going to call mine file PTR. You can call it whatever you want. And as soon as I have that, I have a means to access a file. It's almost like a handle to a file. If I want to then open a file, and this open, the function open really means try to open. If it doesn't exist, do certain things and also return with something. So what the fopen function returns with is the handle to the file or the file pointer. So I'm going to say into file pointer put whatever fopen returns. So fopen goes and tries to open a file and it returns with a handle to the file, and we call that our file pointer. And you need to specify for fopen, you need to specify what the file name is. So I'm going to call my file name my text file, and I'm going to give it an extension txt. You can make it whatever you want, but the txt just tells Windows that the file is a text file and it can open it with Notepad. So when you open it, you need to specify a type, or rather a mode of opening. Do you want to open it as writing, or as reading, or as appending, or as writing with read access, for etc. So in this case, we just want to do W for write. And then as soon as you open it, you might want to think about just closing that file again. So to open the file, we use a function fopen and the file name. And from that point forward, the only interaction we have with our file is actually with the fptr. So we're just going to use the pointer for all the other functions with files. So fptr is what we use to close them. So I want to quickly show you what happens in the file system. Here's my file system. I'm going to run the code, if I can. There we go. Run it, and you should see the file that's just appeared here. Look at the size, it's 0 kilobytes, no size at all. And then if I open the file, it's completely blank and empty. What I want to do now is I want to write something into the file. So there are various ways to do it. The easiest way is to use fprintf. And let's just print hello, here I am, and let's terminate that. So if you look at this function, this is fprintf. It looks exactly the same as printf. It's just we need to add one thing. You need to say into which file you want to write. So that will, beg your pardon, I need to do that obviously before I close the file. And I'm going to print into the file here. So let's run that. What you can see now is in the file system, suddenly it says 1 kilobyte. That's an approximation. If you view it here with properties, you can see now it's 16 bytes. So let's go and look at what goes on inside here. Hello, here I am. Let's just count how many bytes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sorry about that. So if we then want to write something, let's write a bit more into the file. I'm just going to add a new line here. And then we want to write, let's say we want to put a string in there. So the other way to write a string into the file is to use the function called fputs. That stands for file put string. So what you need to specify is, first of all, the string you want to put into the file. So that there, hello, here I am. And then also you need to specify again the file handle. So here I'm going to just type something new in there, and another line. There we go. So if I run this now, you'll see the text file is now a bit bigger. If I go to the properties, it's now 37 bytes, so it's increased in size. And if I double click it, you can see hello, here I am, and another line, which is all good. The other thing I want you to just have a quick think about is that all of those things that I've just shown you are characters. If it's a character, it means that the computer is using some kind of a number to remember that file or that character by. So if I'm just quickly going to browse to the file using another viewer. Here's the file. If I view it, that's what you can see. Hello, here I am, and another line. If I just view this as numbers, so I'm asking the computer, don't interpret the numbers, just show me the numbers. These are the numbers that it shows. So that 48 there, it's a hexadecimal number. You don't need to understand that, but it's a hexadecimal number which relates to the character H. 65 is a hexadecimal character that relates to the character E. And I'll quickly prove that to you. So if I have 48, calc, view programmer, that 48 there is a hexadecimal character. So 48, I'm just going to convert it into decimal. It's the number 72. If I go down into my notepad and I press Alt 72, what pops up is not what I expected to pop up. There we go, the letter H. If I do 65, so let's do 65 in hex, 65 converted into decimal, I get the number 101. If I do Alt 101, I get the letter E. So you can see these are actually the ASCII numbers that are stored inside the file. And the first view that I showed you here, that's just interpreting all the numbers and shown as text as a human would read it. We also have other functions to put things into the file, like put character, fput c, etc. But I'm not going to show those to you now. What you can now do is, after you've closed this file, you can open the same file and you can read from it. So you can, I'm closing it, and now I can open the file, and this time I want to open it for reading. And let's see if I can read from it what I wrote into it. So if Scanf, and again what I want to do is I want to specify the file pointer, fptr, and then I want to specify how to interpret the data that's just read from it. Right, and I want to specify where I want to read it into, so my string. So let's just make a my string quickly, character my string, and let's make it 100 characters, so it's quite long. So now if Scanf is going to read from the file, let's close it, and after I've closed it, I want to print what I've read onto the screen. So printf %s my string, there we go, and hopefully this will do what it's supposed to do. F pointer, that looks about right, yes. So you can see what it does is it reads that hello from the screen. So if I just do the same thing again, if Scanf again, so it opens the file, it does a Scanf to the first white space, because that's what Scanf does, only up to the first white space, and reads it into my string. I do it again to get the second word, it gives me here. Excellent, that's quite nice. I'm just going to move this printf up here to show you what's going on there. Hello, here. Brilliant. What we can also do is we can use a function IfGet. Now IfGet is a bit more useful than ifScanf because you can specify how many bytes it should read, and it goes and reads into the file, or reads from the file up to the first new line. So Scanf stops at the first white space, IfGet stops at the first new line. Just want to get the format here properly. So it's first of all the character string, and then the count, and then the file. So where do you want to read into? Into my string. What's the maximum limit of that variable so that I can't corrupt the memory? So how many bytes to stop at? Stop after 100 bytes, but read up to either 100 bytes or up to the end of the line, and read from this file, and then just print my string again. So what that'll do is it'll find the rest of the string being hello, here I am. So in terms of what the file does, I just want to show you something quickly. When you open a file, like that one there, hello, here I am, these are obviously, each one of these characters is actually a byte. I'm looking at it through a human converter through an ASCII converting viewer like Notepad or something. It converts the numbers into something that I understand. When you open the file, the marker is put there. The file pointer is put there. When I read 1 byte, the pointer is put there. When I read another byte, the pointer is put there, etc. If I do the scanf, so I start off here, I do the scanf, then the pointer points here, and it does the scanf again, the pointer is here. If I do a scanf from the start, pointer goes here, and then getString reads all the way up to the new line, up to that end, and it stops there, and it will read from the next line then. So I'm just going to read the next line as well, just to show you. There we go, and another line. There we go, it stopped. Alright, so that's basically text files, and you can use fputc, fgetc, the characters one in the same vein. But what I want to show you now is quickly how to do a binary file. So first of all, binary files do very much the same as the printf and the scanf, but they don't convert it. They don't interpret any human interaction whatsoever. They literally just copy from memory into the file. Before I do that, actually, I need to show you something else that I forgot about. Let me just quickly show you. Let's also put another string into the file. Put into the file the number 100, and actually let's make it a bit more difficult. Put into the number an integer. The number I'm going to give you is my int, and make it equal to 107. There we go. So that'll put into the file, it'll put my int. So let's just run it again. By the way, I could have opened the file. It stopped working. I've done something wrong. Oh, sorry. That's put string. It doesn't work in the same way. If printf percentage. There we go. Still no luck. And I need to specify the file name, of course, fptr. Right, here we go. So what I forgot to say was you can also just use the video file. I've got a file made. I can open it using. Just want to open it. There we go. I'm just opening it using Eclipse, so I can see my text file. Here it is. Hello, here I am, and another file 107. Now, what is important to understand is, if I open this file again, I'm just going to reload it. It says this, but if I look at the numbers that are stored, there we go. The 107 is made up of, let's say, I think it's that 3130. Let's just confirm quickly. So 31 in hex. 31 in hex, if I convert to decimal, is the character 49. And if I go into Notepad and I type Alt 49, indeed, it's the number 1. So that 107 string, 3 characters, is actually 31, 30, and 37 in hex. That is the ASCII numbers that relate to the 3 characters 107. So I've saved a string. Now, if I go back to the file video, here we go. Now what I can do is I can go and read from the file, and this is where scanf is actually more powerful than getString. I can read from the file and I can say, give me that string as my string and print it on the screen. So that should print out the 107. There we go, 107 exclamation mark. By the way, I'm just going to remove the exclamation mark, otherwise it won't be able to interpret it as a number. There we go, just running again. Nice, and you can see here's the file with the 107. What I can now do, as I said, I printed out that string 107, but I can also tell the computer, don't even consider the string, or don't make it a string, read that string and interpret it as a number, and then print out that number. So I'm just going to do my int I'm going to get from my file, I'm going to take the next string using fscanf, interpret it as a number, and put it into a variable called my int2. From the file, read the string, put it into myInt2 after you've interpreted it as an integer. And then I'm printing that integer on the screen. So that should still print 107. There we go. That's the 107. Okay. So now to binary files. So let's say I now have a binary file which I want to open. So let's make a new binary file. And I'll call that something.bin, my binary file. And the trick with binary files is to understand that a text file is also a binary file. It's just the text file is interpreted and converted from the numbers into the characters and then displayed in that way to you. So all files are binary files, but the text files have got special meaning. That's really the only difference. So if I do this and I want to write to the file, if write, I use two functions, fwrite and fread. The way that fwrite works is I first need to specify from which memory location do I want to write, then how many bytes is one element of what I want to write, so size of int, and then how many of those do I want to write, and those two numbers there are literally just multiplied. That's multiplied by that to determine how many bytes I've copied, and then you just need to specify into which file do you want this thing written. So if I run this, you should see there's a file pop up in your file system. There is not. Okay. Sorry, I made option R here. It should have been W, because W makes the file and clears it as well, but R doesn't make a file. So if I look at my file system now, I can see there's a new file, mybinary.bin. Now I'm just going to quickly show you, if I look at this through a binary lens, I'm just using Total Commander to do it. So if I open it, it has these funny characters. And in fact, if I open it in Eclipse, you'll see it has maybe even different funny characters. I'm just going to refresh here. So in Eclipse, if I open this with my text editor, you can see K and then a few spaces. Alright. Which is not really human readable. However, if I ask it what numbers are used to save this, what are the numbers behind it, you can see 6B, which is hexadecimal 000000. I'm just going to use my hexadecimal converter quickly to look at what 6B is. Hex 6B, and I ask it convert it to me to decimal. Hey, it's the number 107. So what is written here is 107,00,00,00. So that's groovy. I've just saved that file. So that consumed 4 bytes. It's the memory that was written, or that was copied over to the file and then written into the file. I can also copy, or at least write myInt2 if I wanted to, in exactly the same way. Let's just make its value a bit less. Just going to change its value so we can see it. myInt2 is equal to 55. And then write that one as well. And that should do the trick. Right, if I now go here and I reload the file, you can see there's a 37 here. Right, what is 37? Well, 37 in hex is just my decimal 55. Brilliant. So that's all good. I'm just going to change it to something simpler so you can see what I mean. Just the integer 9, run it, alt file, reload, F2. You can see there's the 9. 9000000. And that's just because your computer stores it in the wrong order. It's actually read 00000009, and those 4 bytes are the 4 bytes that make up the integer. Alright, so let's take it one step further then. You can obviously read that data back from the file if you wanted to. Let's just open it for, actually I'm just going to open it for writing and also for reading, save a bit of time. And then fread, I'm just going to rewind in the file, meaning go to the beginning of the file, fptr. So from the beginning of the file, I want you to read. What I want you to read? I want you to read into myInt2, read the first thing that you get in the file, and that will obviously be what we wrote as myInt1 into the file. So into that address, write the size of one int, so 4 bytes multiplied by 1 byte and get it from the file that I just gave you. Then what you want to do is I guess we want to print out what it found. So let's just print out what the value of my int2 is now, and it should print out the value that I got from the file. The value from binary file is good stuff. So now it should print out 107. No, it does not. Missing terminating character. There we go. In and there we go. That 107 was read from the binary file. It's if I just go back to the binary file quickly, here we go. It's that 6b all the way up to the 00. That's converted, or not converted, that's read into the memory into my int2 and then printed out as an integer to the screen.
I also quickly want to show you how to make what we call a random access file. So a random access file is yet again just another binary file, and what it basically means is that you write structures and arrays of structures into a file. So I have here just quickly defined a structure for us. I'm just going to copy that. So first of all, I'm defining a structure. I've called it myStruct_t, the type, and then inside the structure I have an x, a y, and a character array of 4 characters. And the first one of those I've made the values 5, 5, and hell. The second one 3, 3, and LLO. Then one with all zeros, and then one with 4, 4, and XXXX. I've made a second one of those structure type variables, and by the way, the first one was an array, and the second one is also an array, and all the values are made 0. So the first one's called myStruct, and the second one is called myStruct2. So what we're going to do now is we're going to make one of those files, or at least we're going to open one of those files. I'm going to use the same file pointer, which you typically won't do, but in this case it's nice for the example. And what I want to do now is I want to write into this file that whole structure. So in order to do that, I'm basically just going to do an fwrite. As I said, it's just a binary file, but it's more structured. We have complete control of the structure of a file, and in this case the structure is just the structure variable that we've made. So I'm going to write from myStruct, which is obviously the array, I'm going to write 4 elements, and each element is of the size of myStruct_t. So 4 times however many bytes that thing consumes, write it into file pointer. I could have also done this, just pay attention here, I could have also done this and put it into a for loop and say for I is equal to 0, I is less than 4 I plus plus. So that does the same thing. From 0 to 3 including, it writes each one of the, actually I should have just ampersand that, from the address of that element, for the size of one of those elements, times 1, only 1, write into the file, and then in the next iteration it will write the second one. That's the one way to do it, and the second way to do it is to just say, I want to write the whole array. The size of the array is 4, and it starts at myStruct 0. You can do that, or because it's an array, you can just use that, or you can just use that. That's the simplest one. So if I just run this, that would have made me a binary file, and if I quickly go there, or a struct file, and you can see the struct file here. It contains the integer, the float, and then the hell, then integer, float, and the LLO, integer, float, LLO. And if I view this in binary, or at least in hexadecimal binary view, in the numbers, then you can see that there's first 4 bytes there is the number 5. I'm just going to try to move this down so you can see what I'm on about. There we go. That's the 5, 0, 0, 0, 0, and then that A0 40 is the float. So the first 4 bytes is the integer, the next 4 bytes is a 5 represented as a float. And that's why we have to specify when we print out a float or an integer, we have to specify what type it is, because the computer goes into memory, looks at this binary bits or these binary bits and try to interpret the number, and a float and an integer is done differently. Then following that we have the characters hell, just see here, 48, 65, 6C, 00, that's the hell, and then that is followed by another 4 bytes, and so it continues. So you can see the 4 bytes here is actually the 03 that we've got there, and then that's followed by 03 in hexadecimal, or rather in floating point number 03, and that's what that 40, 40 and the 0000 mean. And then we have the LLO there, loads of zeros, so what you can see immediately here is the float for 0 and the integer for 0 is coincidentally the same. And then we have the 4, that's those 4 bytes there is the 4, and then a 4 in floating point is written like that, and then finally the XXX and a trailing 0 at the end there. Alright, so what we want to do now is we want to read that back from the file. We want to read it into the into mystruct2. So we've taken mystruct, we've written it into the file, and now we want to read it from the file into mystruct2. So first of all, let's just assume that we know how many of these structure elements there are in the file. So mystruct2 is where I want to write this into, remember the ampersand, and I want to write into it the size of mystruct t, 4 of those fptr from file pointer, and let's then, after we've read it out, let's just print it out as well. Okay, so I'm going to put this in a for loop. For I is equal to 0, I is less than 4, I plus plus, and then let's just print all of that out again. So what you can see is that didn't seem to do the trick, must have missed something. Let's just have a quick look about what's going on here. So what's just happened is that the file pointer has moved on after I did the write. It was at the end. I just needed to rewind fptr to the beginning of the file, and that should sort it out, hopefully. There we go. There's the stuff that I've written into the file. Now, in this case, we knew how many we've written into the file, but typically you don't know how big the file is. You don't know how many of the structure variables there are in the file. So what we do to get that out is we first do one read of one element, and then we check, have we exceeded the end of file. So the way we do this is, while not end of file, fptr, as I said, we use the handle for all the file conditions, and inside here I'm just going to say, while we've not reached the end of the file, just read from fread. And I want to read, first of all, I want to read into mystruct0. So I want to read into mystruct0 is where mystruct2 starts, mystruct2 0. You could have just left that as mystruct2, but I'm going to change it for clarity. And then I here, and what you want to do is you want to increment I. So while I've not reached the end of the file, and by the way, this FEOF triggers when you've exceeded it. So when you read the last one of the structures, it won't trigger this end of file. You need to exceed the end of file before it reports as we've reached the end of the file. So that's why we read it once first, then enter into the while loop, and then read the next one. And when it comes back, it'll check, have we gone beyond the limits? So what we can do here now is we can actually use, let's use j, another integer, and we say that must be less than I minus 1 and j plus plus, and then we print out what we've read one by one from the file. And let's print out how many we've read. We have read %d records, or what do we want to call it? Yeah, records is okay. Okay, I think all of this should be good. Let's just have a quick look. Small problem here. It's okay. It's okay. And then, sorry, the fread needs to go from the address of my struct2, not just from my struct2i. There we go. So I've done one to few. Let me just see why. So I read it into my struct2. We've read 3 records, and the answer is that, oh, sorry, yes, of course, because we start counting from 0, that should be an I, and this should be an I as well. There we go. So that's the whole story, and now you can check whether you've reached the end of the file as well. And you can do binary files, which is all type of files, and a subset of that is text files, which just means that each byte means it's a character, and you can interpret that through the ASCII table. And then finally, I showed you how to do random access files, which is literally just the it's a structures stored into a binary file. So it's a binary file that's very much structured.